Good evening, ladies and gentlemen, and welcome to this very special session on solar energy for the Palladium Grand. This is a first in the series of the sessions that we will be holding in next few days. The purpose behind these sessions is to abreast ourselves with what is happening in the community outside of the Palladium Grand, what is happening in the country, what are some technological advancements, and what solutions might fit well for we at the Palladium Grand, both for individual flat owners and also for the common amenities as such. We have two very distinguished speakers today. But before we start, let's have a brief 4-minute video that actually help us to confirm some of our understandings of the solar energy and also the terminologies that these speakers will be referring to. So it's a 4-minute video, and here we start.
Photovoltaic system consists of PV panels, which produce DC power when exposed to sunlight, and an inverter, which inverts the DC power into AC power that is fed into the utility grid. 3 different inverter topologies are currently used in PV systems: a traditional string inverter system, a microinverter system, and the solar edge solution. The traditional string inverter topology, which is still used in the vast majority of all installations, has a number of significant drawbacks. In traditional systems, panels are wired in a series as a string. Since each panel has a unique power production profile, which is a function of differences in manufacturing variances, installation parameters, and shading patterns, the entire system's output is limited. The traditional system design requires all strings to be at the same length, using the same type of panels, and to be positioned at the same angle towards the sun. Real-life installation constraints result in either wasted roof space or unnecessary duplication of system components. The DC cables, which connect the panels to a string, carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the panel's DC voltage, and therefore poses serious risks to installers and firefighters. A traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel-level problems remotely. In the 90s, another inverter topology was introduced: the microinverter. This topology takes the functionality of the traditional string inverter and scales it down to fit a single panel. By controlling each panel individually, microinverters are able to solve certain challenges of the traditional system. However, microinverters have their own inherent drawbacks. This topology requires each panel to have its own microinverter with full inverter functionality. Therefore, it has significantly higher upfront costs relative to traditional inverter topology. When we started to develop the solar edge solution, we defined 3 goals: to optimize power generation of each panel individually, to use the same installation methods and components used to install traditional inverter systems, and to compete with the cost of such systems. Eventually, we developed a topology that meets all of these goals. The Solar Edge DC optimized inverter topology combines the best of both worlds. Our solution splits the traditional inverter functionality into 2 products: the power optimizer and a simplified inverter. The power optimizers are located on each panel, turning the panels into intelligent panels. These power optimizers provide panel-level tracking and real-time adjustments of current and voltage to the optimal working point of each individual panel. The simplified inverter is installed similarly to a traditional inverter, but it is only responsible for DC-AC inversion and grid connection. Our solution includes two additional features: a panel-level cloud-based monitoring platform, which is accessible from any computer or handheld device, and an enhanced safety mechanism. When installers install the SolarEdge solution, they use the same cables, connectors, and methods as used in traditional systems, and are able to install more panels to combine long strings with short strings and to install panels on different facets of the roof. The SolarEdge cloud-based monitoring platform provides full data at the panel, string, inverter, and system level. This allows for immediate fault detection, real-time alerts, and comprehensive analysis. These important features reduce operation and maintenance costs. In addition, we have incorporated panel-level safety mechanisms to protect installers, electricians, and firefighters. With the SolarEdge solution, whenever AC power is off, the string's DC high voltage is automatically reduced to a safe voltage. This solution meets new safety regulations in all significant PV markets around the world, as well as the 2014 National Electric Code in the US.
Okay, so this was just an introductory video to get everybody familiarized with the terms, terminologies, their definitions. May I request the speakers to turn on their cameras and others as well. Good morning, Ritesh, for you out there in the United States.
Morning.
And we are recording this session. So even though you may see less number of flat owners actually attending, this is often one has to do if you are in a service leadership kind of a role, that you will have to become a servant to the others and feed them right to their mouth. So with that, I would like to invite a very dynamic young entrepreneur. I met him about 2 weeks back and we instantly clicked. He has been on the front pages of the newspapers, on the page 3 of magazines for the work that he has done at his housing complex called Scorpio in the Hadapsar area of Pune. Very young, and I believe the kind of passion with which he is working, he has many rewards, awards, and applauds to receive in his life to come. With this, I invite Rahul Ranjan of Oricon Developers to present before us what he has done at the Scorpio housing complex in Hadapsar. Over to you, Rahul.
Thanks, Vishwas. That was quite generous description of what we're trying to do. So, hi everyone. My name is Rahul, and I'm actually a real estate developer. And we essentially wanted to create a building that was extremely efficient in every manner, including energy and water. And so during the construction phase itself, we tried to incorporate a lot of those technologies, came up with some new new methods of doing things, and it was quite out of the box at the time. It is still quite out of the box for a lot of people, but we kind of achieved it. I would say that whatever we wanted to achieve, the goal, how they say, aim for the stars, you reach the moon. It seems like we have reached a good amount of that distance. So I'll just actually, Vishwas, I was wondering if you're going to show the other 4-minute video of Scorpio, because I think that would have given a short rundown. Or do you think that everyone's already seen that video?
We have circulated that video enough number of times.
Okay, perfect. Fine. So everyone has an idea exactly of what it is, right?
Yeah.
So I'd like to share screen. Let me just see how
Yeah,
do I do that.
go ahead. You are not allowed.
Oh, I'm just trying to figure it out how to because
If you go down on the bottom, there is participants, chat, and share screen.
oh yeah, share. My God, right in the middle. No, I'm on my tablet actually, so it's not my PC.
Okay. Yeah, we could
Can you
see
see it?
yeah, we could see your slides. Yes.
Okay, let me see if it's,
Yes, Rahul, we can see your screen.
yeah, just trying to see. All right, right. Okay, so
everybody, I'll request everybody else to please put your call on the mute because there will be some disturbances, external disturbances. So
Sure.
whenever you need to speak, please
I
put on the mic.
I think Rahul is outside, right? This is the wind
yeah,
noise that is blowing. You know, it is because of Rahul's wind noise.
okay, I had a feeling of that. Just
If
give me a second, yeah. Just
no,
hold on.
Rahul, what you can do is you just mute yourself on the speaker and let the video run, so we can hear the video and see the
Oh no,
video.
this is a PDF file that I had wanted to explain. So just give me a second. I'll just
Okay,
move inside.
okay,
Yeah.
sure, that would be great. Thank you, thanks you. It seems good right now, whatever place you're in.
Okay. Rahul, I think that has taken care of the wind.
Yeah, that's because I had muted myself. Just give me a second.
And rest everybody, if you put on mute, the video will not click to yourself, you know, so maybe you can put on mute and have a look at the video if needed.
Is that better now?
It's much better. Go ahead.
Perfect. And one more thing I just wanted to tell you, know, everybody can put on mute, and if you want to speak, you don't need to remove from mute. You just press your space bar. It will automatically unmute you. Leave the space bar. It will mute you back.
Okay. So I'll just begin now. So the current situation in terms of solar in most societies or anywhere that's being done, that where they have a shared roof amongst multiple tenants, right? So in all of these places, they are essentially just getting solar installed purely for their common areas or the common amenities. And what essentially happens at this situation is, yes, their common amenity bill essentially becomes zero, but the rest of the roof, there's a lot more roof that could be utilized, but we have no idea what to do with it. So the traditional solution is to give individual systems to individual apartments. And the problem with that is that firstly, the entire system cost increases because you got to have the entire set of accessories that go into solar for each and every apartment and each and every system. So assuming you have 20 apartments in a building and you have one common meter. So you need to have 21 inverters, 21 AC cables, DC cables, earthings. See, these are all technical terms, but by just letting you know that 21 sets of this, you can just imagine what the overall cost is going to be. And when I want to do this for my own building, I see I have 24 apartments there. I was like, I can't have 25 sets of everything. I mean, not only is it not financially viable, it is not physically possible. And that's why if you see anywhere, there's no one has the ability to get solar into their individual apartment. And the other problem that I can that we could foresee that is that there will be some discrepancies in terms of the panel positioning. Some people may say, why is his panels in the front and my panels at the back? This is a society. The roof is shared. They like it. My panels should also be in the front. What we have done essentially is that we have taken the entire system on the roof. We have covered the entire roof with panels, and we have made that as one system. So they're not 25 separate systems. There's one big system, and that's a shared system that is going to be used for every apartment and for the common. So let me just tell you about why solar even makes sense. So the first important thing, I mean, at least in my view, is it's the carbon footprint. Just going solar reduces your carbon footprint dramatically. It's one of the easiest way to reduce your carbon footprint as on date. You don't have to be do some drastic other things by just putting a few panels on the roof. You are essentially helping to save that, helping to save the planet. But let's forget the carbon footprint issue, right? What are the other benefits of solar power? First, the most basic thing is, yes, you're generating electricity and you're reducing electricity bills. That's the main reason why most people go for it, and that is obviously understood. But there are other benefits to it. So uh, you must be aware, like, how societies I mean, most people don't want to get panels. I mean, don't want to take a flat on the top of the roof, under the roof, so on the top of the building. The why they don't want to do that, because they say that during summertime their apartment gets really hot. In this particular situation, when your entire roof is covered with panels, um, the whole building cools down. The idea that the top flats get hot during summer is half true. The entire truth is the entire building actually gets hot. Thermal radiation has the ability to percolate through mass. So that heat can percolate all the way down to the first floor. Obviously, it reduces as it goes down, but the entire building gets hot during summertime because of the roof being hot. So what happens when you cover your entire roof with panels is you're essentially casting shade on your roof, and the whole building naturally just cools down. This is called passive cooling. You're not using any electricity to cool. That when you use electricity to cool, like with the AC or a fan, that's called active cooling. But here, by just casting shade, you're cooling the building without using any power. So your entire building stays cool. So all the people who even living in the apartments underneath it, they feel naturally comfortable even during summer. And even if they turn on the AC that needs to run for 3 hours will basically work only for half an hour, 1 hour. So that is indirect savings of power again. So that's one big benefit that you get from covering the entire roof. The second huge benefit for societies is that when you're covering a roof with panels, and because of the shade, you're reducing the amount of heat hitting the waterproofing of it. So if you can see, that's written here, the third point here is that the difference in temperature between day and night, that's called the delta T. That difference is drastically reduced. So if it's an uncovered roof, during the day it'll expand, like mass, anything, any mass expands during matter expands during heat, when it is hot, and it contracts when it becomes cold. So during the daytime it expands, night it contracts, and next day again it expands. So this cycle, over the course of 3-4 years, every society starts getting leakages from the roof, and that becomes a big costing problem. There's a big maintenance involved. People are unhappy, and it's generally a big mess. And every society normally goes through this. But because of the roof, that delta T reduces dramatically, and because it reduces dramatically, the life of the waterproofing increases again exponentially. So even during monsoons, the rain that comes down from the sky comes and pelts your roof, and it pelts basically those cracks that are formed during in an uncovered roof. So now when you cover your roof with panels, it hits the panels first, then it falls down. So the kinetic energy of the raindrops gets basically blocked out by the panels. So yeah, so in this manner, your waterproofing life, I expect to put more than double, because now my current building has been 3 years and not even a single hairline crackle I can see on my roof. So which is, in my view, it's tremendous. And yes, we are in India, so I mean we have so much sunlight, it's insane. So this is one of the quotes which you can take from Elon Musk, who is like a pioneer in climate change technologies. So which is amazing. So he says that we have a handy fusion reactor in the sky. You don't really have to do anything. I mean, it just shows up every day, right? So you can generate power every single day. And I mean, you don't have to do anything about it. It's not like wind that is dependent on when wind blows. So like I was explaining earlier regarding every apartment getting power compared to only the common areas. the traditional systems right now have all these issues. So you can say that the cost and efforts to do every individual net meter is significant. The cost of solar inverters is extremely high. So the cost of inverters is actually reduces dramatically when the size of the inverter is high. Okay, I'm directly going a little slightly technical. I'm not going too technical here, but I'm going slightly technical, assuming that people have an idea of how solar systems uh, are I mean what the overall system comprises of, because we have got panels, we have got solar inverters, then we have got net meters. So I hope everyone's clear on that. Vishwas, if you can just give me like a
Yes,
idea
I
from
think that's a good baseline to assume. So
yeah.
you could go ahead. Yeah.
Yeah. So solar inverters, if you're going for a 1 kilowatt inverter, it may cost around 20,000 rupees, 1 kilowatt inverter. Then if you go for a 50 kilowatt inverter, it may cost you probably, I think Chetan is better to answer that, but I'm just giving you an arbitrary number of approximately 70,000 rupees or 80,000 rupees. So you're essentially getting 50 times the kilowatt rating, but the cost is going up only 4 times. So this is what the scale of price to kilowatt to kilowatt rating of the inverter is. I mean that price drops dramatically. So instead of having small 1 kilowatt inverters for 25 people does not make financial sense. So what we have done essentially is that we have made one big inverter for one big system. And yeah, I have already mentioned all of these points, Valley. The complexity of cabling, the troubleshooting and maintenance solar systems on individual scope. Yeah, this is another big point. If one person's solar system does not work efficiently, it becomes his personal duty to go and get it done. And it's not even his forte. He does not know who to contact, who is he going to work on it, who's going to work on it, is it being done properly? You know, that becomes a big issue. And for small systems, not many people are very interested to go and they're not very big customers generally. So it's a regular vendor may not find that as a big priority for them generally. But here, when you have a big system on on a particular roof, so you're talking a 50 kilowatt system, 60 kilowatt system. If there's some issue with that system, the entire society, it becomes a responsibility of the entire society. The entire society ends up calling that the vendor, and then that work happens in a priority basis. So that's the other benefit of being in this manner, right? So here's the comparison of what direct comparison of how we can say this how the balance of system between a traditional manner and what we are giving the solution. So this is called the smart solar PDU. You can see the device there. So this is what you installed for every apartment. Okay, gets installed in the meter room. So it reduces the need for individual inverters and we essentially get one big inverter, like I mentioned earlier, and we have one of these devices for every apartment. And then what this device essentially does is it limits for each apartment to get a certain amount of power. Now, let me just give you an example how that works. We do a calculation for every building of how much power can go to every apartment. Let's, for ease of calculation, assume that in your building, we can give 100 units to each apartment. Every person may have a very different power usage pattern. So some people may finish their 100 units in 10 days, some people may finish it in 20 days. But whenever they do finish it, it automatically switches from solar to the individual MSAB meter. And on the first of the next month, it switches back to solar and gives them fresh 100 units. So it's an intelligent system that detects exactly how much power you have used. It switches over to your regular MSAB meter, and then you switch back to solar in the next month. And the biggest benefit of this is like you end up saving a lot of money due to it dropping you a slab in the MSCP bills. Now I'm pretty sure all of you are aware about MSCP's slab rates. So the first 100 units is extremely reasonable, it's extremely cheap, and from 100 to 300, the cost goes up significantly higher. Then from 300 to 500 even goes higher. So when you're essentially when you're initially priority on solar, and then you're going to MACB, it drops you down a slab. Let's assume that you're using your 200 units a month, every month, and you're getting 100 units here. So your top 100 units, which is basically from 100 to 300, you're in the 100 to 300 slab, which is more expensive. It takes you down from that slab. So you end up saving a lot more money because of this, right? And the entire complexity of the system is reduced. This is a fit and forget system. Once you fit it, you don't really have to go and monitor it. It does its work by itself. And it's quite intelligent. I mean, it has got safety features within it. So it has over voltage and under voltage protection. And there are some other safety systems that you need to add to it in this when you're installing this. But the solar installers, whoever is going to be installing it, will be directed exactly to do that. So that'll be part of that their installation guidelines. So this is the wiring. It's just called the single line diagram. So this is how it's going to be installed. So this is just an overview of it. It's a simplified version of it. So we have the panels generating power goes to the solar inverter, and from the solar inverter it comes down to the bus bar. The bus bar is essentially a distributing panel. From there we tap the connections and give it to each one of my devices, which are called the SPDUs. All right. So the SPDU has two sources of input and one output. The two sources of input, one of them is solar, the other one is your MACB meter, and your output is your apartment, right? And like I mentioned earlier, it switches on from your initially your priority on solar. When you finish your solar, only then it switches on to your MACB meter. On the first of the next month, it goes back to solar. And this is how it reduces the bill dramatically. Now, in my building in Scorpio, I think 90% of the tenants have not paid an electricity bill for the last 2.5 years. That's because their consumption is generally low, because the building itself is generally efficient. But some of them just cross the 120 units now, which I've given them. They have crossed that only during summertime, because that's when they turn on the ACs for a very long time. So what are the features of this device? So the device basically gives prefix solar kilowatt hours delivered to each consumer. No one can cheat the system. Only when they finish that 100 units or whatever the set units are for your particular project. Only whenever they finish that is when they switch on to MACB. They cannot go. So if, for example, this limit is 100, they cannot use 150. Like the system will not allow that. It's not possible, right? We can do different variations, but in your case, I think we'll be just doing it 100 units flat. Then we have another version where we can give only between daytime, 10 a.m. to 4 p.m. But we normally suggest that only to societies that have very low power going to every apartment every month. So there are some societies that we have seen only 15 units per month per apartment, or 20 units. But I think for yours, we have designed, I think Chetan had given an estimation of 85 units. So you have a good amount of units. So you don't have to worry about that. I'm currently developing version 2, so that is connected and it is intelligent. The version 2, so we are reaching there. It's under developing. We can say it's an we're in alpha phase. We're reaching beta phase. That should be done. Yeah. So this is like a good you can say a good way to visualize exactly the differences. So in case of 15 apartments or offices, like in this case is apartment, you need to have 16 inverters there. Whereas here you have one big inverter. Instead of having 16 small inverters, you have one big inverter. And the cost of this one big inverter will be extremely low compared to all these 16, right? The number of net meters is as well. There's a you can see the difference there. I mean, you need only one large net meter compared to 16 net meters. And the cost of net meters as well is quite high, which you take from MACB. There are other charges, special charges that you have to give at MACB, which I think everyone's generally aware, and the time taken to do that. So you save a lot of money there as well. And the cabling installation cost as well is extremely low. So okay, let me just say something which is out of the presentation here. This is my purely my view, and I mean, I don't see it being better anyway. There is no other efficient manner to distribute electricity in every apartment from solar than this, in terms of physics, with the current technology that we have today. I don't see there being any other point of view. I mean, I've taken a very physics approach to doing this, and in my view, there's no other way to do that. So, most societies know only about using solar for their common amenities, but for the first time, it's actually possible to give that to every apartment. And if you have that roof space and the society can afford it, I highly recommend everyone to do that, because it's not just about generating solar and reducing your bills. There are other benefits which I've already mentioned, and you're saving the environment. And I keep using this line for a lot of people who I meet, is that there are very few things in life that come about that you buy it for one thing, but it gives you multiple benefits, 4 or 5 multiple benefits, which have nothing to do with the original reason what you bought it for. So this is one of them. So I implore all the societies that have the capability to do it. Right, Vishwas? I think I'm ready for some questions if anyone has.
Thank you, Rahul. Before you take on the question, I think it will be appropriate if I show that 2-minute video
आवाज कहाँ चला गया रे?
about the solar tech, about the Scorpio, so that people who have joined late gets a view of what it means.
Vishwas, can you not show this one? Sorry.
Okay, I don't know. I don't have the other link at this point in time. With me.
It's actually it's there at in the mail which Chetan had sent. So it's the first link. Yeah, if you can just
okay.
Yeah. So
Yeah, just a minute.
The solar powered apartment. Yeah, that one, yes.
Some days the technology takes you for a ride a little.
Yeah, just
We've observed many times that some builders will install a solar water heater system and some basic rainwater harvesting in their buildings and call it a green building. Oricon developers have taken this to an entirely new level. They have installed a 41.28 kilowatt solar power system, which generates 5,000 units of electricity every sunny month. Let's talk to Mr. Rahul Rajan and find out more about the solar power system. Rahul, tell us a little bit about the solar power system you've installed there.
Yeah, so we have installed a 41.28 kilowatt system, which can generate up to 5,000 units per month, which has to be sunny. Now, most of the energy will be going to every apartment actually. So we are going to be giving 100 units to every apartment, and then the surplus of that will be used to run the common amenities of the area. We have designed it and we thoughtfully calculated exactly how much we need to generate to provide all these amenities, and we have achieved that.
Awesome. So basically, you are kind of going to be in a surplus.
Yeah. So we will be in a surplus because we don't want to make sure we don't want that on a sunny month also they have a deficit of electricity. So there has to be enough for them to also use in their apartments, and so that everything else works, all the communities. So the 41.28 kilowatt solar system is connected to a net meter. The reason we have done that is so that we can export the excess electricity that's being generated that's not being used. So what happens is that like when in the night when there's no sun power, then the excess electricity that you have exported, that can essentially take it back. So MSEB or the electricity board acts as a virtual battery.
Right.
So in this situation, what happens is continuously, even though there's no sunlight in the night, they're still getting solar power through net metering.
Fantastic. 4 months of a year in Pune, you have a pretty cloudy weather. It's the monsoon season. And is there a drop in the production of electricity over here?
Yeah, definitely, because the cloud will obviously reduce the amount of sun rays that's coming in. But generation drops to around 60 to 65%. So because of that, yes, there is a drop in power. But how we have compensated here is that excess electricity that's generated during the sunny months. We expect that to have like a accounting system by through our electricity board. So that will be used here because of the deficit.
All right. So that makes it up
During the
monsoon.
But now this year we had 6 months of monsoon.
Yeah,
so clear sign of climate change. I mean that people should understand.
We are here at a very special room in this building, which is the favorite room of all EV lovers. This is the meter room.
Yeah.
Now let's go and
Okay.
wow, I can see there's a special device attached close to the meter of each flat.
Yeah.
Can you explain what this is?
So this is a device that I made especially for this building because I was trying to figure out how I could split electricity and distribute it between every apartment.
Right, you said that you're giving 100 units free to each member, to each apartment.
So that comes through this. So on the first of every month, there is the meter resets and it gives you 100 units to use.
Right.
Only once you're done with the 100 units, it moves on to the grid, your grid.
Oh,
yeah. So for example, by the 20th of the month or 25th of the month, you finish all your 100 units and you go into that. Again, after the 31st, on the 31st night, going on to the first, it'll reset back and give you additional 100 units. So this way, each apartment is getting 100 units, is distributed equally, there's fairness. It's not like some apartments getting more than the other.
So was this a device that you could easily buy off the shelf?
No, because this solution wasn't there actually in the market.
It's such thoughtful feature and devices you specially designed for people. This is really awesome.
Thank you.
Thank you for sharing this with us.
Thank you.
Mr. Rajan's team has installed motion sensors on every floor that turn off lights to save electricity. All common areas are fitted with energy-saving LEDs.
Okay, so thank you. I think that shall give an idea why we invited Rahul to come and speak to us, because when we thought about solar energy for Palladium Grand, we did not only think about the common areas, but we wanted to make a difference in everybody's monthly bill that comes in. We are indeed running late. If there is any pressing question that anybody has for Rahul, then we should please raise your hand and shoot your question to Rahul. And then after 2-3 questions, we would probably go to Chetan, who has studied the Palladium Grand and he has arrived at some solution. So I see Pankaj wanted to ask the question. Pankaj, go ahead.
Rahul, thank you for everything. And thanks, Vishwas. Now, I want to know what are the chances of bus bar going defunct? With the voltage RC, due to RC or due to some repairs going on and whatever may be the reasons, what are the chances of bus bar going defunct and what are the consequences?
See, the bus bar is essentially just a box with the copper, how do you say, copper plates, like long copper plates, which there's no mechanical part in it. There's a fuse box also attached to that. I think Chetan will be a much better person to answer this than me, but there's a fuse bar attached to that. And sorry,
you continue, because as I understand, the heart of the this entire concept is the bus bar, right?
Oh no. The heart of the system is basically for distributing every apartment is the SPDU, the device which you must have seen in the video next to the meter. Yeah, so that's called the SPDU. It's not called the bus bar is a separate, just a box.
See, what worries me is some problem has happened, and just a hypothetical case that I'm taking.
Yeah, sure.
That little bit of work I had done on this. So this hypothetical case came into my mind, and that's what stopped me from converting my flat into the solar. Okay.
Okay. Yeah.
The some problem has happened, and the MSCDCL department is carrying out some repairs, and the reverse current flows.
Okay. So the answer to that is the inverters that we get, especially the inverter that we are proposing for your society as well.
Yeah.
They have something called as so what you're calling is an islanding issue. It's called an islanding issue, right? So
Okay.
it's where MSCB turns off the power, but solar still generating, and that backflow current goes and see the reason they even turn it off. MSCB turns it off is because they are doing some work on the line. You don't want current going there and electrocuting the person working there, right? So the inverter is connected to the grid. So there are grid tied systems. As soon as it detects that MSCB is off, the inverter shuts off. It shuts down. See, okay, here's the other. I mean, again, I'm just iterating it because most people are not part of the solar, may not be aware of this. That's why I'm just answering that. Solar power, a grid tied solar system, especially the one that we are proposing here. These are not backup. It's not a backup system for power. It is a supplementary power source. So it is along with grid with MSCB, right? It works along with MSCB. If MSCB shuts down, the solar will also shut down. If you want it to work, if you want solar to work when MSCB is shut down, then you need to include batteries in the system. And the batteries, if you install it in 2022, is extremely expensive. You all can explore this probably in 2030, where that time lithium-ion batteries will be more reasonable. But as on date, the most cost-effective and the best ROI and all of those calculations they will take into account is to go to a grid-tied system, and the grid-tied system will shut off will also shut off when MSCB shuts off, right? So yeah. I hope that
Pankaj, Pankaj, if you can narrate a problem, probably we would get
Yes.
You can write on WhatsApp. I'm going to take a last question, and that's from Ritesh Shetty. Ritesh, good morning to you. And
good morning. I have put my questions in the chat box. I don't require an answer right away, but Ranjan, I operate out of US, okay, and I'm in US right now, and I do have solar systems on my roof put in, okay. Having that, we have a difference in the country and the development countries, So one question is, what is the return on investment at the rate of 85 units being given to each flat? You don't have to answer it right now. I'll if you can answer it on a later date also is fine with me. And what is the annual maintenance needed for this one? Do you have an annual maintenance plan that needs to be done every year, and that is at the cost? What is the cost of it? What will each flat system need to bear? See, we live part apart, and we don't want a gold-plated system, but we want an sustainable system. Okay, you perfectly told that 2030. I would say 2040 is the right era to speak on a battery. So today Elon Musk is looking into it, and when he does everything, we'll look into it on later on date to put it. The third thing what I wanted to ask is, why do you want to put it on the roof, and why don't you take a place and do a farming, solar panel farming, electricity farming, by giving to other societies also in and around, so you don't have to put it on the roof, and if something goes wrong, if any reason, the maintenance of it becomes very costly. So that is what people do it here. They buy a farm, and I do have wind energy, I do have solar energy. I'm a part of Excel Energy part for wind energy. I bought wind energy. I'm in the reduction of carbon footprint. I do look forward. Today it might not be benefiting me, but I want to be a part of that going forward. I'm a responsible citizen, that my future generation looks at it in a different way.
That's
so
great.
Yeah, so I'm not looking at electricity bill reduction or so, but putting it on Palladium Grand and everything. So what is the return on investment, and how many years would it take for me to get back that money? Is my lookout. I don't want day one, something investing, even a child to be born, it takes 9 months, and elephant takes 18 months, so you cannot have one, you put it on the roof and the next month you start reaping benefits of it. But at least a feasible number that can convince everybody is my thing,
So solar, so there are some things which I think Chetan will be better to answer than me, but I'll just give you a few things which I can answer quite confidently. The cost of the ROI of your system can be anywhere between 5 to 7 years. Okay. If you take financing, it may go up a little bit more, but you must be aware that the solar system by itself, the products like the panels and the inverters, like they have extremely high warranty from the manufacturer itself. It's not the life of the system; the warranty itself is 25 years. So, so if you get an ROI of basically 7 years. Okay,
that's good.
And after that, essentially, you're for the next 18 years, you're generating free electricity essentially because it's already paid off, right? That's the first thing. Second thing, what is the maintenance? Again, AMC's Chetan is the best person to answer, but this is a non-moving system. It's literally like you've installed an angled floor. Like if you've taken marble and you've just angled it and you just installed it. What is the maintenance? You just have to use a wet mop, no chemicals, just water and a mop. You have to go and wipe it. That is it. There's no other maintenance to this. You could AMC charges that can come is basically for going and checking the other things. I mean, Chetan, I'll let Chetan answer that. But otherwise, in terms of your daily maintenance, there's nothing. There is literally nothing.
Okay. So Rahul, before you go, I have Kaushik. You wanted to ask the question, but I believe you have finished answering to Ritesh.
Yeah, I think
okay.
Whatever is there in the chat, you can take it forward.
Correct.
I'm good.
Kaushik, go ahead. Kaushik. Okay. Okay. I think Kaushik is a bit away from the system. Go ahead, Kaushik, and ask your question. You are mute. You are mute at the moment. You have muted just now, so unmute. Yeah, go ahead. Yeah.
Probably he's got some mic.
I think so. He's moved away from a mic, or his mic is not connected properly.
If you could type it down as well, we can answer that.
We can't hear you, Kaushik. Okay, so while Kaushik is fixing his microphone, let's move ahead. Today, the next speaker we have is, first of all, thank you, Rahul. Thank you. I know that you had a busy day and you agreed to be our first speaker. Obviously, we are learning throughout this series of talks that we will have, because there's a lot of, it's not about technology, it's about social re-engineering and changing people's mindset to accept something unconventional. So, and I always say that technology is actually a percentage of it. 99% is working with people's mindset, people's philosophy, and their understanding of the forward-looking path for sustainable future. Thank you very much. Chetan is one who works with Solar Age, and he has visited Palladium Grand, and he has prepared a solution. So what he is going to do in next 15 minutes, if it is possible, Chetan, you can present a solution. And obviously, once you present a solution, the first question is going to come is about the cost of the system. And then that would derail or put everything into the track, or it will put everything off track. But over to you, Chetan.
Good evening, friends. So I'm just going to explain.
So we are at
What studies
10:25
I have
at
done
this
about
point in
your
time.
society.
Chetan,
It's basic purpose.
if you can speak until 10:40, will be great.
Yeah, sure.
Okay.
So
And
am I audible?
if you are audible. If you have a presentation, you can share.
Yeah. So what I have done is that I have actually done an energy analysis. Okay, I'm just sharing my screen. So is it visible?
Yeah, your screen is visible. Go ahead.
Okay, just okay. So you have actually 9 meters into the society. Okay. Within one is the clubhouse, and there are 2 meters for individual buildings, for one for the lift and for the common.
You need to speak into the microphone and little louder.
Now you can hear me?
Yeah.
Yeah. Okay. So what I have done is that I have done an analysis for complete year. Okay. For each meter. Okay. If you can just see, so these are like readings from like complete year readings, and I have taken an average. So in some months you will be getting a bit higher, some months you will be getting. So if you take it as a building lift, so your consumption is around 430 liters. Okay. In this way, I have actually done it for all the meters. Okay. And this is the summary of it. So if you see for building A, your consumption is like 413 plus 130. So if you calculate all your buildings plus clubhouse, your like consumption pattern is around 4,600 units per month. Okay, and average billing, what you are spending on this is around 66,000 to 70,000 in between. Okay. And if you calculate the rate for per unit, what you are spending is around 12 rupees 29 paisa. Okay. And then if you see the systems, what is required for the common is around like 44 kilowatts of system is only for the common. So for 44 kilowatts, I would require around 4,000 square feet. Whereas for each building, we have almost 4,000 square feet. So we are left with like around almost 4 other buildings where we can actually generate more electricity and which can be distributed within the flats. So in that way, I have actually calculated as like number of flats is 140. For each flat, we can keep up to 85. And we have actually calculated the heat pump as well. Okay, so heat pump is basically giving hot water to each flat also. So if you consider in a flat, the most consumption part is first is your uh, uh, geysers. So we'll be reducing 85, and this, if you calculate, it will be like around 175 units per flat we can reduce your heat. Heat pump is just an exception if you want to take it, because most of them would have already bought geysers, some have not. So we can consider this units also can be distributed to each flat. So considering all this, we require consumption of your consumption will be around 32,000 units on a monthly basis, and total year is like 3.9 megawatt, whereas we can generate almost 3.95 megawatts on your terrace. Okay. How I have come to this is how the solar is generated. So in a market, how we calculated is that a kilowatt can generate around 4.4 units to 4.4 units, depending upon what technology we use, what inverters we use. So anything between 4 to 4.4 units you will get for a 1 kilowatt. That's the okay. So we can almost this is just a understanding pattern. This is not the right way to show, but if you need to show how much we can generate, is like there are 2 types of panels available in the market. One is the polycrystalline, one is the monocrystalline. Polycrystalline is a byproduct, so it has the energy what we can generate in per kilowatt is around 3.8 units to 4 units. And if you take a monocrystalline panels, you can generate between 4 to 4 units depending upon the seasonal events. Okay. So this is just a difference that I want to show why you have to go to monocrystalline panel and not polycrystalline. Polycrystalline panels are cheaper on the side, but the production is also on a lesser side. So if you think on a yearly basis that monocrystalline panel will generate almost a lakh of units more than a polycrystalline panel. If you are considering like 250 kilowatts of system as a whole. Okay. This is just a terminology that itna generates how much units we generate. So we actually do a stimulation report. If you place the panels on your society, calculate what are the shadows, calculate what are the soiling happens. So this is just a stimulation report. So this is your society. Okay. We have actually taken all the, if you can see the image, can you see the image?
Yes, yes.
Yeah. So this is like on a very basic scale that we want to show. If we lay down, okay, so our consumption is around 393 megawatts on a yearly basis, whereas we can generate around 405 megawatts in a year. So this is actually a stimulation report. I will just, this is a technical bit. Okay. So if you see the last page of it, so this is a system loss diagram. So when we generate electricity, it is into a DC thing, which converts into AC mode. There are system losses, then irradiation losses. So all things has to be taken into consideration. So if you see the all things, model quality loss, optimizer, shading effects, everything has been calculated. Okay? And this is still an stimulation report. Okay, so it's that much we can generate. Okay, and it's entirely dependent upon the system. And if you see the loss factor also, so the soiling we have considered that there will be % of soiling on the panels, where that will begin generating a less. And in India, almost every in a month, 3 Thursdays, electricity will be not there. So I consider that also in a period of like 3% I calculated as in a whole year there will be no electricity where we won't be able to generate because grid is off for maintenance purpose. Come to a conclusion that we can generate almost 405 megawatts of energy from 250 kilowatts. Yeah.
Chetan, I think either you are not holding your microphone properly or you are moving away from it. So you are dropping on and off.
Okay. Shall I repeat it again?
Yes, you need to.
Can I say something?
Yeah.
Okay. So this is actually your terrace top of the building.
Chetan, can I ask you something? It should not be megawatt here. Megawatt is a too big unit.
It's a megawatt.
No, it can't
4
be.
lakhs. So 250 kilowatts.
405 kilowatt hour.
This is annual consumption.
So if you see the monthly, I will just show you your energy consumption. Okay. Yeah. It's a 4 megawatt, 4.5 megawatt.
4.5 megawatt annually.
Yeah.
Okay.
Annual.
Okay.
Yeah, go ahead.
So see what I will show you. I will just show you again. This is your average monthly billing of units, right? I've calculated 140 lakhs multiplied by 85 units plus heat pump on a monthly basis will consume this much, and this will be the total consumption for you as a whole society. The number of flats, the common amenities, and everything. Okay, so that is my achieving target. Okay, this might be a lesser, this might be on a higher side. So how I have calculated is running a stimulation report. It's 4.05 gigawatt. Right. So our consumption is like 3.93 megawatt, and we can generate up to 4.05 megawatt from 250 kilowatts of system. So coming back to the ROI system, okay, I will just show you. Can you see now?
Go ahead.
Yeah. So what we'll be saving is around like 175 units per flat. Today's MACP rate for second slab. Have you been to? I will just show first the MACP rate chart. Okay. So this is the rate chart for MACP. These are the latest rates coming from it. So if you see like 100 to 300 units is like 8.69 units. It's the basic cost of it. Then there is a wheeling charge, or we can say it's a carrying size, which is adds a like 1.38 per unit. So this will get added. And this total, you will have to pay like 16% of tax. And when you divide, it will come to like 11.68. This is for 150 units if you can consume. Okay. This is from the 1st of April what the MSC will be charging us. If you go to second slab, the second slab is more costly. In the same manner, it will be like 15 point. This will be for 3-4 months, they are saying, but most likely again it will come down. But still the rate will be like around 10 rupees per unit. Okay. I will come to the ROI part. So considering the unit charges, okay. So will be giving 175 units as a total with heat pump and 85 units to the per flat. Okay. This thing is just.
Chetan, you have this issue of a microphone which you are not holding properly.
Yeah. So you can see.
Now we lost you for last 1 minute, Chetan.
Now you can see I wasn't not talking at all.
You wasn't speaking. Okay.
No. Okay. I just want to just tell you the ROI is only completely based on the unit pricing. Okay. Every year MSCB gives like there is a 2% increase in unit pricing. Okay. So this year is like for 100 to 300 unit is like 11.68. The next year will be. So this is an increase in. So on 25th or 27th year, we'll be paying like 15 rupees, right? So if you consider 175 units multiplied by this thing, so 24,000 rupees per flat will be saving on a yearly basis. Hello.
Yeah. Okay. Go ahead.
Yeah. Okay. So that is one saving. The second saving is for the. So you will be requiring like 55,000 units for the society. This will be your saving. So ROI, there are different types of calculate your ROI. Okay. So we won't be able to get GST benefit or the depreciation benefit because we are not a profit making. So whatever the savings will be done on the unit basis is the only ROI. So for a residential zone, anything between 5 to 7 years is the ROI. In your case, it will be like around 6 years if you take a look.
Okay, so if I understand you, mota, what you are saying is that if we implement this,
right,
on a flat per flat, we would save around 24,000 per year, and whatever that we are spending currently for common amenities,
you will be saving like
around 50 to 60K.
Yes.
Per month.
Per.
Okay. Good. Go ahead.
Okay. So I will again just come to the stimulation report.
Sorry, 1 second, Chetan. Which was last time when we had come to the office.
So this is what actually we calculate given the stimulation. Yeah. Hello.
Yeah, go ahead.
Yeah. Rahul, you wanted to come in.
Yeah. Sorry, Chetan, just give me a sec.
Sure.
I just want to remember, did you all say that in your society, on an average, each apartment is using approximately 200 units per month?
200 to 250.
200 to 250.
Yeah. So you all save a lot of money. I think in terms that, essentially your 150 units, your 150 of your units are on the expensive slab. If you assume 250 units per month, out of that 150 is on the expensive slab. So you will essentially be dropped down from the entire expensive slab.
Correct.
So the kind of savings that you will be experiencing will be much greater here. Yeah, just a caveat to that.
Yeah. Okay. Great. Chetan, go ahead.
Yeah, and then we'll come to like technology part of it. So this is like MSCB. I will not go into the bifurcations and this thing. So why solar age and why not other different things? So if you have, if you have seen the first video,
Chetan,
yeah,
there is consistent problem. Either you holding the microphone or you are being moving back and forth from the system. So
no, I'm actually a standstill. I'm just checking my internet connection as well.
Okay. Okay. Good.
In fact, Vishwas, I can hear him
Now you can hear
properly, clearly.
Okay.
So
Okay.
why,
So,
if you're not using a headphone, kindly use one in the laptop.
Okay.
So when we are actually started designing for the society, so we want to give like better protection for the society that whatever we choose a product should last like at least whatever the ROI plus double the that we should get the money. That's what we are thinking. So there are number of panel companies, number of inverter technologies available in the market, which is falls under first three companies in throughout the world. Okay, there is a suggestion why we want to give this inverter is because of the shadows. Okay, so we have south facing, but if you see in our terrace there are leaf pools, there are water tank, moving shadows all the way. Okay. So we'll be also doing a shadow analysis when we start with like if we go ahead, if we want to do all this thing, then we first have a shadow analysis based on this thing, and then we'll. So Solar is a company, is an Israel company manufactured in China. Okay, and basically this gives an upper hand. So if you consider like if you complete put it all the panels on your society, okay, so number of panels what we'll be installing is around 460 panels. Okay, in that one panel gets is like it's not working properly. So unless I come to your society, I check all the panels, uh, I won't be able to know which panel is it. So in this, I will be able to see all my panels, their voltages, how they are working, and everything at a given. So one panel also falls in, I know which panel is have an issue. So that's the best part of it. Second thing is the shadow. So what happens whenever we do electrification for the panels is into the series. Suppose I have to install 50 panels on one society, one building, and 10 panels is called as a string. So what happens is a shadow or a pigeon comes and sit on the panel, production drops, and in the series, all the panels also fall. So my production for that panel drops to like 60%. In that series, all the panels go for a 60% production. But in this, it only hampers that panel. The first video what we have you have shown was regarding the solar age inverters. The terminology is what we were talking about. So this carries a 12-year of replacement warranty, and this will last more than 25 years because there are no moving parts into it. Then there is an called as an so this is the solar age inverter. It's like listed on the Nasdaq also in US. So most of the residential go for solar age only maximum times because they have sloping roofs and over there. So that's it. And this is called as a power optimizer. So this what it does is actually placed under the each panel. So what the key analysis is, it's my individual panel is a production unit, not as a series. So that's where this we get more, almost 4 to 5% production more than a normal inverter. And this carries a 25 years of warranty, replacement warranty for optimizers, which actually work under the panels. Okay. Any questions on this?
If I may start a set of questions,
Yeah.
the panel, the inverter that you are proposing,
Yeah.
is not manufactured right here in India.
No, sir.
Okay, so
If you
therefore,
just to interview, almost 90% of our products will always come from China.
okay,
Sorry to say that, but it's a fact. When I'm suggesting the panels as well. So if you take the Vikram panels, which everyone knows, the chips are coming from China itself. Here we are assembling. Now the production has started in India, but it is not gone to that level where China is now.
okay. So because there is also another aspect for a group of flat owners like ours or a housing complex like ours is
Right.
to be benefit from the subsidy programs of the government of India, because that
Absolutely.
itself is a huge reduction in terms of our
Absolutely.
net cost that we will have to pay. So that was my first thing. But I'm just opening the floor for the discussion. Please
I'll just stop sharing.
raise your hand. Anyone who would like to have any particular doubts. By the way, all that Chetan has presented, he has shared earlier. So we will share all of those documents with all of you, so that you also can go through it, because watching them on the screen and reading them makes a huge difference. But anybody has a question, please raise the hand. Yes, Dada. You need to unmute yourself first. You need to unmute.
Okay. Pankaj has asked the same question I want to ask further. What exactly is the protection provided in inverter for shutdown of the grid? Under voltage, under current, whatever.
So
What is that?
basically the inverter is
Yeah.
actually have two different boxes. Protection from the AC side, wherever there is a fluctuation, the box will actually, which is called an ACDB box, okay, for the AC side. So any surge protection, anything, the fuses will go off from the boxes and not from the inverter. Is designed in such a way that it can absorb like more than 2.5 times what voltages are there. So if you consider like voltages coming from MACD won't go like more than 300 volts. 240 is the benchmark. If you consider the surges, that won't go like more than 300.
So
If
you have over voltage protection also.
Yes, we have to have. Over voltage protection is not a problem. The low voltage protection is a big problem. So in over voltage, low current also we have.
A low current so you should have.
Yeah, it is designed in that way. Right. And itself means all the inverters, not only SolarEdge, all the inverters have that protection. Like if we are considering like 100 kilowatts of inverter, that can take a load of almost like 150 kilowatts of.
So is it MCB sort of thing? Which
yes, yes, it's a MCB, like surge protections are there. MCB is there.
Right. Okay.
Okay. Thank you, Dada. Anyone else has a question? Sandeep?
No, I'm okay.
Okay. Ritesh?
No, I have put it on chat, and I had a few questions which I put it on chat. Maybe it's being answered on time. The last question, what I would ask is, do you have any alert mechanism stating that something is wrong, and because it is on the top of our head and it is not on the top of the company's head, any alert mechanism which says that, oh, something is there and something is wrong, you need to put this off, or something that really goes wrong? Wild question. Okay, is that something like that?
It's a very good question, sir. Thanks for the asking. So SolarEdge is like whenever, first of all, when there is no electricity, okay, the panel still generates electricity, which has to be shut down. If you see the video, it is the most safest part is that the electricity teams, yes, The second thing, all the internets, all the inverters are connected to the internet. So on your phone, on our system, we are always getting if overloading is happened or low production or there is no internet also. So all production analysis and everything.
I couldn't understand. He's not audible. He's getting cut off. Sorry, Chetan, you're getting cut off.
Okay, Chetan, let me answer this.
Yeah.
In terms of the protection, there are already physical protection in place. Okay, physical protection in place for in case there's a short circuit and everything, the system, the inverter detects and shuts it down. Okay, there are ACDBs and DCDBs which themselves have fuse boxes and everything. So if there's an overcurrent or there's something there's an anomaly, the fuse itself will blow off and it'll stop the generation. Okay, that's the physical protection, and then there's digital protection as well. So tomorrow, for example, there's something happening, and the solar edge inverters itself are very, very advanced inverters, and their monitoring is on a panel-to-panel basis. You must have seen that in the video, literally on the panel-to-panel basis. So if there's any panel that's behaving as an anomaly, not just like there's some safety issue, even if it's not generating enough, it sends an alert saying that this particular panel has a certain problem. Please check it out. The system gives that alert. And we can digitally also turn it off. That's what Chetan was trying to say that earlier, that the system is connected via internet. So we need an internet connection in place in a society, right? But and what's going to happen is, if there's some issue that needs to be checked, or y'all even tell, like, there's some, it's not generating enough, can you just cross check that, Chetan? He can just go online and see immediately what's happening there. So you have a digital protection, but even if, for example, internet's not there, physical protections are in place. And probably Chetan can add if there's something I've not covered.
Thank you. Thank you, Rahul. I have one question to Chetan. Chetan, with
yes,
the solution that you are proposing, what is the cost for per kilowatt of generation? Or from the concept to installation and operations?
So I've already shared you with my quotation. It's not only the solar product. So we have considered all the things from MSCB, what we would require, the meters, the installation from end to end. Okay. So now if you consider only solar part, it's around like 55 or 58 rupees per watt. So that is the pricing what we have given to you.
So it's around 58K per kilowatt.
Considering all these things and total extension and everything. Okay, that would come to around.
And this is excluding the SPDP. No. Including the distribution units.
I'm just telling you. So if you see my quotation, the first part is my solar plant. Okay. The second part is like solar power distribution to each flat. Okay. Then the third part is the MSAB part, the load extension, net metering, and the disconnections over there. So total is like going around 2.2 crores as a whole system.
How much?
2.2 crores.
For how many kilowatt?
242 kilowatts.
240 kilowatts. Okay.
Yeah.
So around 1 lakh per kilowatt.
Yes, sir.
Okay. Now, then another of my question, if we say that we want to take a benefit of the subsidy programs of the government, so we request you to change the material.
I'm always open for that. The only thing is that when it comes from the central, I will be the first person to tell you that yes, it is coming from the center and you will get this. Now what has happened in last 3 years, the subsidy is coming from central to the state and it is not getting distributed. That's why is the issue. Now again, in another month time, the central government is taking complete charge. And if that happens, I will be the first person to tell that you should take a benefit. That will actually reduce your ROI by an year, I guess.
Yeah, that
at least like 9 to 10 months at least.
Okay.
That will be huge. So roughly what I can tell you is like around 7,400 rupees per kilowatt you can get a subsidy.
Okay.
Okay, but for that you have to use a Made in India channel panels. That's a compulsion.
Oh.
And I'm not denying Indian made panels are also equally good. So nothing to worry about. It's just the technology advances what like German people and we are like, it's like Volkswagen and Maruti we can compare.
Anyone has any other questions to either to Rahul or to Chetan? Philip, Prashant, Pankaj is done, Kaushik, Ritesh. If not, then I'm going to say thank you to both of you, Rahul and Chetan. You guys are the opening batsmen in a sense of the series of awareness and learning curves that we will go through in next few weeks or a few days. What we are trying to do is to bring the people in terms with the future developments that are taking place towards sustainable future. And then in terms of the processes, what our thinking is that once we are confident that we have learned enough, we would come up with a RFP, the request for proposals, with as and when we arrive at the consensus from the majority of our flat owners, and then release the RFP. So you will have yet another chance to quote your best prices at that point in time. And then we shall see how we will be able to take things forward. So with that, Rahul, thank you very much for taking your time out. And Chetan, thank you for making an effort to visit the Palladium Grand, spend a couple of hours with Sandeep and Bimal Sinha, and also to present the proposal in the shortest possible time. So thank you guys for all your patience, and wish you a wonderful day ahead, and good night.
Good night.
Thanks, everyone. Good night.
Thanks a lot. Good night.
Hey, thanks everybody.
Thank you.
Thank you.
Thank you. Yeah.